All right, session 6 lab. Today we're going to be debugging a DLL to deobfuscate and extract shellcode. Today we're going to be looking at this x.dll malware sample that we have. And the first thing that we're asked for is to determine what memory allocation API is being imported by this DLL. So I went ahead and I dropped this into PE Studio, and if we go to our imports, we can see that virtual alloc is being used here. And then we're asked what section um, of the PE file do we think the obfuscated code is in? And if we're just looking at entropy here, we can see that this section 1, this our data section, has a 7.9 entropy, which is very high. So we can deduce that that is where the obfuscated content is. Then we're asked to look in Binary Ninja and determine what exported function from this DLL is the logical candidate to execute for debugging. We could just see the names of the exports here. There are 6 of them, and they're all kind of just random characters, and then you have this XXX one. And so if we go into Binary Ninja and we go to our triage view, you can see here that I search in the imports for virtual alloc, and that will take us to this function here that's calling it. And then if we kind of trace up the line of function calls, we see this one goes to this WJYB one after this QT one. And then if we go there, you can see that it's actually being called by XXX. So again, looking back at our exported functions, we can then determine that XXX, this exported function is the one doing the virtual alloc. So this is the one that we want to actually debug further. Then we're asked to just make sure our configurations in x64 debug are correct, which they are. I won't show that, but they are. And then we load, using run dll32.exe, we load that xxx exported function and the x.dll file into x64 debug. You can see here that I have that configured. And I actually had already ran through all of the debugger analysis, and it takes time. So I did grab some pictures that I took, screenshots showing kind of what we've figured out. But basically, we are asked, once it's loaded in, right, the first thing that we do is we basically start by running the debugger so that we get past the run dll32.exe, actually running like that operation, and we actually land into the xxx.dll within the debugger, right? We would see it on top saying that we are in xxx.dll. So we went there. Then we had set a software breakpoint on virtual alloc, as you can see here on the top. And then we ran that to get to the place in memory, or sorry, get to, we had gone to the instruction for virtual alloc. We then executed till we returned. Then we had gotten, I don't think I have a picture of it, but we had gotten, by looking at our RX value for our return, that we, the memory location, and then we had then followed that in our dump window initially. And then what we had done was we set a memory on access breakpoint. We had then continued our execution, and then um, we had basically gotten to, is this my dynamic? Yeah. Let me go to my static. We got into this point in the code where we were able to see the do while loop of some sort of mathematical arithmetic operations. some byte shifts and all this that is a little hard to kind of deduce what's really going on. But this is basically the deobfuscation, right? So we had then set a breakpoint. Back to my dynamic. We had set a breakpoint here, which had been the end of that do while loop. And we then took a look at the memory region, and it was kind of a bunch of nonsense. We had a lot of zeros uh, before the actual, like actually readable ASCII data. It wasn't really readable, actually. It was just kind of a bunch of nonsense. I didn't even find any words in there. And so um, we had then, based off of the lab's recommendation, uh, considered that the program may need more time to fully deobfuscate the content. So we set a memory on execute breakpoint at the beginning of the region of all those zeros and just kind of nonsense characters. Um, then we had ran it again. Now I can actually start showing some pictures. Oh, actually, I have a picture here of what we had seen. Um, this is what it looked like before we kind of kept running it, but it was uh, several lines of zeros, and then this kind of this set these characters here. So really nothing that we could deduce. Um, and so, yep, we continued executing, and then we were able to start seeing some actual readable words and strings. So still a bunch of zeros, but yeah, we see here, you see potentially the start of get proc. Oh yeah, you can see get p and then rock address. So you could, yeah, so you're seeing something there. We see exit. We see heap. Looks like heap alloc actually. And so yeah, we dumped that to disk. Um, and so I actually can pull that up real quick in my, where was that? That was my dynamic. It was, I believe, this one. Yep. So we opened it up in hex editor. We had a lot of zeros, so we went ahead and removed those. We then ran it in speakeasy. See if I have the initial command I ran. Yeah, so this is it initially. Um, we can see that heap alloc and get proc address for heap alloc was being used. And then obviously we timed out, but we saw what I guess the initial what shellcode looks like initially. Like this is like the beginning as it starts to um, uh, I guess load libraries in runtime. So we were then asked to set a breakpoint back in x64 debug for the load library A and load library W API functions. And so from there, we were able to land, pull this back up, we were able to get a hit on load library A, sorry, and you could see here an RCX and in R14 and those registers that were loading WinINet. And so then we did execute till return once again, and we basically landed here. Now that we're where my x64 debug is actually at, um, we landed here, and we did see the call here, this call RBP, which is what actually did that load library of WinINet. And so it looks like it is resolving WinINet in runtime. We can confirm that. And then we were asked to where are we? then dump the code. So we then had taken our code, or our memory here. We followed it memory map. We dumped it, and we then threw that in Speakeasy, and we can then answer the lab's questions of what domain it was reaching out to. You can see here this resources.avtechupdate.com, and then um, seems to be infographics auth icon is also a part of the request, and our user agent, which is, where am I? It's right here. So yeah, that's the lab.